What's up guys, it's Iman Fiaz and today's video is on AQAS level chemistry June 2017 paper 2. This is label the horizontal axis in figure 1, energy. In figure 1, sketch a distribution of molecular energies at high temperature. So it's going to be something like this, right? What is it? The maximum peak is lower displayed right to the original. There we go. Given that increased temperature increases the rate at which the gas decomposes. Increase in the number of molecules with energy greater than or equal to the required activation energy, so more successful collisions in a given time. Calculate relative molecular mass of X. I'm going to use PV because NRT, but I'm trying to find the MR of something, relative molecular mass. I'm going to find out the moles. N equals PV divided by RT. Pressure in pascals, so 102,000, times by the volume is always measured in meters cubed. In this case, I've got a centimeter cubed, so 72, times by 10 to the power minus 6, aka divided by a million, divided by 8.31, times by temperature in Kelvin, 373. That will give me the moles. Moles is mass over MR. MR is mass over moles, 0.194 grams. That's in milligrams, so milligrams to grams, I just divide by 1,000 over the number of moles. And then give it to the appropriate number of significant figures. And then, what is it? 0.194 divided by number of moles. 81.88, so 82. Which is two significant figures only. Calculate empirical formula of Y. Also, different hydrocarbon shows that contain this much by mass of carbon, so 100 minus 83.7, because hydrocarbons compounds containing hydrogen and carbon atoms only. So 100 minus 83.7 can be 16.3. Therefore, I can do carbon to hydrogen, 83.7 divided by 12 to 16.3 divided by 1. Therefore, it's 16.3 to 83.7 divided by 12. 6.975 divided by smallest molar ratio, so 6.975. So I get 1 to 16.3 divided by 6.975. 1 to 2.34. And if I times that by 3, then I'll get 7.01, which is basically 7. So times both sides by 3. I can't just say 1 to 2 because it's not like 2.01. Then I could say that it's 2.34. So I got to times it by 3. So I get 3 to basically 7.01. So 3 to 7. Therefore, empirical formula is C3H7. Now the molecular formula, well, the MR is 86. MR of this, 12 times 3 is 36 plus 7 is 43, so I want the MR to be 86. I'm just timesing it by 2, so C6H14. Roti, record my video.
Roti.
Wait, who's downstairs?
Uncle Emden and Uncle West.
Okay, record my video.
Roti, salad.
Okay, go man. I'm not on mute.
Salad.
Then it says, yeah, that's it. I thought it was asking for names of him as well. That's what I was expecting. No, question 3.1. State the meaning of terms. There are some explain how to use rising compound B, and then some other stuff as well. So, stage 1. Well, A and B are unsaturated because of decolorized bromine water, aka they contain carbon-carbon double bonds, alkenes, as they decolorize bromine water. Whereas C is saturated, not contain carbon-carbon double bonds, it's an alkane. Actually, the cycloalkane, but yeah, alkane, as it does not decolorize bromine water. Stage 2, suitable names for A, B, and C. So for A, well, I know it's unsaturated. There's contained carbon-carbon bond, so it can be pent-guanine. It can also be 2-methyl-buteguanine, 2-methyl-butetuene, and B is equal to pent-2ene. And C, well, C, because it's C5H10 and it's not contained C11C, it's going to be cyclopentane, not pentane, cyclopentane. Yeah. And then stage 3, explaining differences. Well, explain what stereoisomerism is. Stereoisomerism, molecules with the same structural formula but a different arrangement of atoms in space arises as C1's carbon-carbon double bond cannot rotate, and EZ isomers, where each carbon in carbon-carbon double bond has 2 different groups. Or you could show by drawing the EZ isomers of B. Question 4, an equation for the complete combustion of propane. Methane, ethane, propane, C3H8. I'm adding oxygen, and I know because complete combustion, my product's going to be purely carbon dioxide and water. 3 carbons there, 3 carbons here, 8 hydrogens there, I need a 4 here. How many oxygens? 6 plus 4, 10, so I need a 5 here. Introduce the molecular formula of this alkane, and I know alkane and carbons, that's that. Enthalpy of combustion is equal to that. Introduce the molecular formula. So I can say, well, the negative, I divide by negative, so I can just say then 496 N plus 202 constant negatives equals 6650. Therefore, if I do 6650 minus 202 and then divide by 496, I get N equals 13. To use the molecular formula is alkane, and it's going to be C13H28. Because an alkane, CnH20 plus 2, C13H28. It's just one reason other than the use of mean bond enthalpies by volume. Enthalpy of combustion liquid alkane is different from volume obtained. It takes energy to convert it to gas. It's a liquid alkane. It takes energy to convert it into a gas. Plot the enthalpy change, the combustion of this against this, and then use estimate enthalpy of combustion for 1 gram of propane. So it should just be smooth line best fit curve, and then you know what to do. And then go to propane, 3 carbon atoms, go there, and then let's say it was here, and then you read off your value. That's what you do. I'm not going to go through that, to take a lot of time. Just do your graph and do that. Isooctane, component petrol, when it's burnt, enthalpy is that. Calculate heat energy release from this much of that. So what I can say is heat energy release, I can say the mass equals 0.692 times by 1000, because it's 1 dm cubed is 1000 centimeters cubed, which is 692 grams. Therefore, to find out heat energy released, well then isooctane so 692 with mol of cycle isooctane So then do that times by the enthalpy change for example, and you should get 3.31 times by 10 to power 4 kilojoules. Question 5, calculate the mass in milligrams of the acid in 25 centimeters cubed solution. So find out the moles of sodium hydroxide, find out the moles of this, and I want to know the mass of that. Well, then I can find out the mass very easily. So first things first, moles sodium hydroxide 0.30 divided by 1000 times by 0.500. Then divide it by 2 to find out the moles of the H2C2O4. Then I'm going to use, what am I going to use? Moles is concentration volume. No, I'm going to use moles mass of MR. I've got the volume and I want to find out the mass. Oh yeah, moles mass of MR, mass is going to be the moles times by the MR, which is 2 plus 12 plus 12 plus 64. But I want it in milligrams, then times by 1000, and then I get 569 milligrams. I think that's the reason it's worth 4 marks for that final trick. Grams to milligrams. Remember to times it by 1000. Student uses the wash bottle tube containing this to rinse the inside. Explain why this improved accuracy. Ensures all ethane dioic acid / reactants are in the mixture. Give the meaning of the term concordant titers. Titers that are within 0.1 centimeters cubed of each other. Titers that are within 0.1 centimeters cubed of each other. Shows all the ethane dioic acid / reactants are in the mixture. How many questions are left? Alright, not bad. Question 9 question 9 and 8 are basically like very short questions. So it's basically question 6. So name and outline mechanism. Alcohol be made by reacting a halogen alkane with dilute aqueous sodium hydroxide, nucleophilic substitution. Nucleophilic substitution. Mechanism for it. Well, methane, ethane, propane. I've got 1 bromo, 2 methyl propane, and it's just going to be nucleophilic substitution. So lone pair of electrons, OH minus, partially positive, partially negative, attacks partially positive carbon, CBr bond breaks, and then yeah, that's all you need to show. In terms of 2 centimeters cube, this react with this, density is that, current percentage yield. So first thing I'm going to do, I know density is mass over volume, therefore, because a lot of these questions are the same, like it's just these calculation questions. So first, find out the mass, find out the moles, 1 to 1 molar ratio, find out the moles of that, then work out the mass of that, and then do actual yield or theoretical yield times by 100. Same process. But you can see here they've added a trick, milligrams, and you convert to grams, but it's not anything like too difficult. So the mass is going to be 2 times by 1.26. Now for the moles of this, or it doesn't give you the MR, so you need to work out the moles. But in this case, it gives us the MR of both the compounds I need, so it's fine. Over the MR. So 2 times by 1.26 over 136.0. Use 1 to 1 molar ratio to work out the theoretical yield, aka the expected mass. So moles and mass of MR mass is going to be the moles times by the MR, which is 74.0, and that's going to be 1.37 grams as theoretical yield. Now I'm going to do actual yield, 895 milligrams, so 0.895 grams over that times by 100. So 0.895 over my answer times by 100. I get 65.3 65.3%. That's what I get. The mark scheme, it says 65.7%, but it also says allow 65 to 67%, so that's fine. 65 to 67%. Find out the mass, find out the moles. Oh, it's because it's not 136.0, it's 136.9. I just misread that, that's why. Now, let me try it again. 136.9. 2 times by 1.26 or 136.9. That's the moles. Then do that times by the MR of the propane monols, 74. Then you get that 1.36 or 0.895 of my answer times by 100. Yeah, perfect. I get 65.7%. Just misread the MR for 1 bromo 2 methyl propane. 1 bromo 2 methyl propane reacts a hot concentrated ethanol with potassium hydroxide. Well, the name of the mechanism is elimination. Naming of the product. Well, let's just go through the mechanism right now, because why not? So 1 bromo 2 methyl propane, because I want to see product. CBr, CH3. One pair of electrons, OH minus. Acts the basics, proton on left carbon spare electron. Once form a double bond, CBr bond breaks. Then what happens is you've got CH2, CH3, got a double bond here. You've lost the Br and you've lost the H+. Yeah, that's all that happens. So naming that product then basically, and it's going to be, well, methane, ethane, propane. It's methyl propene. Methyl propene, and that's what I would recommend. Like, especially for me, I find it difficult to do name organic product from just this. So then just go through the mechanism real quick. Put your hand up in the exam, ask for a spare sheet of paper, and just draw it out really quickly. It doesn't have to be a good sketch, and then you can see what the product will look like, and then name the product, and then there you go. So methyl propene, that's really bad writing. Methyl propene elimination. Complete mechanism for the conversion of this into 1 cyclohexane. So, dehydration reactions, what happens? It bonds to the H+ here, Then you've got this. You still got this H3C. Still got this H. But here you've got OH2 positive charge here. And from middle of this to here. And then what happens is you've got your carbocation, and it wants to form a double bond. So double bond forms there. Just again, how well you know your mechanisms. George structure is different cyclic alkene formed from carbocation D. Well, instead of that happening, the double bond could, yeah, the only other way is that you've got this, but the double bond's here. Yeah. Regional results of carbocation explained as rearrangement takes place. Carbon D can undergo a type of reaction called rearrangement to form carbocation E. This reaction, hydrogen atom bonding pairs electron move from carbon A to carbon B as shown. In figure 2, rearrangement takes place. So we need to talk about stability. More stable carbocation formed as changes from, well, that looks like secondary carbocation to tertiary carbocation. Yeah. More stable carbocation form change from secondary carbocation to tertiary carbocation. As a result, rearrangement in question 7.3, third alkene is formed reaction. Draw the structure of this third alkene. Rearrangement in question 7.3, third alkene can be formed. So I've got the carbocation there, then hydrogen here, the carbocation there. Or what I could have is double bond so you form a double bond here, or you can form a double bond there, or what happens is you can form, let me draw this, double bond CH2, you lose a hydrogen here. Identify factors that influence boiling points of each of the compounds and explain why cyclohexene can be separated from reaction mixture. So cyclohexene has van der Waals forces between molecules. Cyclohexanol has hydrogen bonds between molecules. Phosphoric acid has hydrogen bonds between molecules. And then you need to talk about, well, cyclohexene has the weakest forces. How is it separated? It's separated by fractional distillation. Cyclohexene has the lowest boiling point, hence boils off first. So cyclohexene has van der Waals forces between molecules. Because cyclohexene there, cyclohexanol, phosphoric acid. So identify factors that influence boiling points, and it's each of the compounds. Cyclohexene, van der Waals force between molecules. Cyclohexanol, hydrogen bonds between molecules. Phosphoric acid, H3PO4. Yeah, H3PO4, but it looks like that. That can also have hydrogen bonds, so it has hydrogen bonds between molecules. Cyclohexene has weakest forces, is separated by fractional distillation or simple distillation, but fractional distillation preferred, as cyclohexene has the lowest boiling point, hence boils off first. Draw skeletal formula 3-methylbutanol. So methane, ethane, propane, I'm going to have 3 methyl, 1, 2, 3, methane, ethane, propane, butane, but then this bit's going to be the aldehyde bit. So the C double bond O and the H. This bit is just the methyl. So neighbor carbons 1, 2, 3. That's the third 3 methyl. And then butanol, C double bond O, and then your H. Just played from the C5H11Br. That is a major product when 2 methyl reaction between that with that 2 methyl butene. So methane, ethane, propane, butane, butuene. I also got 2 methyl butuene. So hydrogen, 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 hydrogen. I've got hydrogen partially positive, Br partially negative. Goes there, and then either one cup electrophilic addition, yeah, to form. Well, it says major product, so which one is going to be bonded to is going to be it's going to be here then, because here if the bond's here, so let's say the hydrogen's here then, and you move the double bond and you get the point, and that's carbocation here, lone pair of electrons, Br minus bonds here, that's secondary carbocation. But if it was here, well, that's 1, 2 tertiary carbocation, so that's going to be major product. So it's going to look something like CH3, CH2, CH2, CBr. That's what the Br is going to be. Then your CH3, and then your CH3. CH3, CH2, CBr, CH3, CH3. George structure, thermal cracking of hydrocarbons produce molecules that are attacked by electrophiles because they have a high region of high electron density. George structure, one of these molecules that contain 4 carbon atoms. So we can draw but1ene, but2ene, any correct structural formula of alkene with 4 carbon atoms. So yeah, let's do but1ene, but1ene. So structure, methane, ethane, propane, butane. Actually, I'll do but2ene instead. Why not? So there. Here's a double bond. That goes, sorry, here, here. C4H. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Explain how PVC melts at high temperature than chloroethene. PVC is bigger, has more electrons, greater MR, hence therefore PVC has stronger van der Waals forces between molecules. The intermolecular forces. Reduce number of hydrogen atoms in this molecule. Well, you're going to have 1, 2 there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You get the point, just count them and you should get 38 hydrogen atoms. Use understanding of the properties of PVC. Explain whether you expect to find plus size of PVC used to insulate electrical cables. Well, it is present. You would expect to find plus size in PVC used to insulate electrical cables, because PVC needs to be flexible, because PVC needs to be flexible. George displayed formula for repeating your polychloropropene. So polychloropropene you've got CH2, CCl, CH, and CH2. So it's just going to be CH2, C1C, you've got your Cl here, hydrogen here, and then your CH2. And remember, repeating unit, display from repeating unit, so show the bond sticking out. And that is the end of section A.